All right, so let's solve the problem, which is x cubed y triple prime minus 4x squared y double prime plus 8x y prime minus 8y is equal to 4 times the ln of x, and here x is assumed to be positive. All right, so this is the Cauchy-Euler. I'm going to apply the method of the Cauchy-Euler. Right, I'm going to the Cauchy-Euler method, which is basically doing the transformation, and the transformation is, the step one is to do the transformation, that is x equals e to the t. When I do the x equals e to the t, as I've shown earlier, what happens is that here, by the way, d, whenever I use the d is the derivative with respect to x, right? And whenever I use the script d, that would be the derivative with respect to t, right? So some books might have this as a dx, and some books might have this as a dt, and that's okay as well. But I'm going to use this and this for my purposes. So why am I doing this? So now, whenever I have this x times the d as an operator, that is basically x times the derivative of a function with respect to x, turns into simply d over dt, which is the script d. In other words, what I'm saying here is x dy, that is x times the dy over dx, becomes dy over dt, right? And that becomes that. Similarly, what happens is that x squared d squared y, or x squared d squared, turns into d operated on d minus y, and x cubed d cubed turns into script d of d minus 1 of d minus 2, and that's what I'm going to use for my purposes to transform. And then and then we will see how does this differential equation transforms into in terms of t. When I do that, ladies and gentlemen, what happens here is going to be the following. This x cubed y triple prime, right, is basically now is going to become, let me rewrite this in the operator form. So I have x cubed d cubed y minus 4 times x squared d squared y plus 8 times x dy minus 8y is equal to 4 times the ln of x. Now this transforms into the following. So this is going to be script d of d minus 1 of d minus 2 of y as a function of t, not as a function of x anymore, right? Minus 4 times script d of d minus 1, and as a function, it's a y of t. Let me move this back over here. And then plus, I'm going to have 8. This is a script d of y. Script d of y. And then I am going to have minus 8y. Again, here, whenever I say y here, y is a function of t, right? So now that is going to be equal to 4 times, and then the ln of x is equal to, our substitution is, our substitution is here, x is equal to e to the t, and so therefore the t is equal to ln of x, so therefore this becomes simply 4t. Now I have to simplify this. To simplify this, ladies and gentlemen, what I am going to have is, I'm going to have a d cubed, or d cubed y. Here from now on, y is a function of t always, right? And then minus 3d squared y, and then plus 2dy minus 4d squared y plus 4dy plus 8dy minus 8y is equal to 4t, right? So now if I simplify this further, I am going to have d cubed y, and I have 3d squared, and I have 4d squared, so that's going to be negative 7d squared y. Then I have 2dy, 4dy, and then 8dy. That's a 14 plus 14 dy. Then I have what? Then I have 8y is equal to 4t. All right, so now if I rewrite, if I find the characteristic equation for this, right? The characteristic equation is going to be m cubed minus 7m squared plus 14m minus 8y for the homogeneous part, right? Now I'm trying to find the yc, right? That's my characteristic equation. And for this, if I factor this out, I am going to have m minus, what am I going to have? I am going to have m minus 1 times m squared minus 6m plus 8 equal to 0. If further factor this out, I am going to have m minus 1 times m minus 4 times the m minus 2 equals 0. That tells me m equal, if I write them in the increasing order, it's going to be 1, 2, and 4. And so therefore, my fundamental set of solution for the homogeneous part is going to be e to the t, not the x, right? And e to the 2t, again, not e to the 2x, and e to the 4t, right? And so therefore, the yc for this problem would be c1 e to the t plus c2 e to the 2t plus c3 e to the 4t, right? Now I have to find the yp because it's a non-homogeneous problem, right? So to do that, let me find the annihilator for this one. The annihilator for the non-homogeneous part, right? The annihilator is, what is the annihilator? Simply d squared, right? It is simply the d square. I should not say the d square, I should put a script to d square, right? The second derivative will make that 0. So therefore, this is my GFD, right? This is my GFD, right? And this is my f of m. This is my f of m, right? So if you take a look at this, so to find the yp, I'm going to take a look at the f of m multiplied with the g of m, and that's going to be my characteristic equation, right? Kind of characteristic equation that's going to give me f as nh. So that would be m, that would be m minus 1 times the m minus 2 times the m minus 4 times m squared equals 0. And therefore, the fundamental, the solutions to these, right? The solutions to these are m equals 0, repeating twice, 1, 2, 4. And therefore, f as h, f as h, or f as nh, f as nh would be, I don't think I have enough space there, so let me write it down below. And that would be a constant, and t, because it's 1 times e to the 0, t times e to the 0, and then e to the t, e to the 2t, and e to the 4t. So if I do the f as h, f as nh minus f as h, and if I basically cancel, subtract this from this, right? You see that this will go away, that will go away, and that will go away. So that set is going to be 1 comma t. Therefore, yp would be some constant. I'm going to go with the alpha times the first one plus another constant times the second function. So we are going to have alpha plus bt. Now what I am going to do, I am going to plug this function, I am going to plug this function into my original differential equation, right, which is this one right here, and then solve for alphas and betas, right? And that is the idea behind that. Let me do that. So if I plug it in, let me copy paste this so that you know what I'm trying to do. Literally copy paste it, right? So here's the differential equation that I have. So if I do that, what I'm going to have will be the following. I'm going to have so let me find, to do that, by the way, let me find the yp prime. Yp prime is equal to simply beta. Yp double prime would be 0, and yp triple prime is also going to be 0. And so therefore, this is not going to contribute anything. That's going to be 0. And this is also not going to contribute anything. So that's going to be 0. So what I have here is, I have 14 times the derivative is beta minus 8 times alpha plus beta t must be equal to, that must be equal to 40. So this tells me 14 beta minus 8 alpha minus 8 beta t is equal to 40. And so therefore this must be, for this equation to be satisfied, this must be equal to 0 and this must be equal to 4. I should say better that this whole thing must be equal to 4. And so therefore minus 8 beta is equal to 4 tells me that beta must be negative 1/2. And if I plug this in to the other one, the second equation that I have right here, then I have 14 times negative 1/2 minus 8 times the alpha is equal to 0. And that tells me negative 8 alpha equals positive 7, right? And that tells me that my alpha is equal to negative 7/8. And I figured out my alpha and beta. So if I plug it back in, if I plug this back in here, you would agree that my yp and my alpha, yp is going to be negative 7/8 negative 1/2 t. Let me change them to a different color. So that's what I have. And so therefore the general solution in terms of t is going to be y as a function of t is going to be c1, what do we have, yc plus yp, right? Yc is c1 e to the t plus c2 e to the 2t plus c3 e to the 4t, and then the y, this is my yc, right? That's my yc, and my yp is basically this right here. So I should change this to negative. So that's my yc. That's my yp. So that's my yp right there. Now we are not done. We need to rewrite this in terms of x. The substitution for that would be, you know, that x is equal to ln of t. When I do that, then the y of x now becomes c1 e to the ln of, x is equal to e to the t, I'm sorry, x is equal to e to the t. In other words, t is equal to ln of x. So it's going to be e to the ln of x, which is, by the way, x, and this is c2 times e to the 2 times ln of x plus c3 e to the 4 times ln of x. This is much easier, by the way. Plugging this isn't much easier, but again, just showing it for some of you. And then I'm going to have negative 7 over 8 minus 1 over 2 ln of x. So if I rewrite this, then solution would be c1x, because exponential functions are inverse of each other with the logarithmic function. And again, this is a logarithm, so I can bring the power to there as x squared, and then exponential function, so it's going to be c2x squared. Then the next one is going to be c3x to the 4 minus 7 over 8 minus 1/2 ln of x. And that is how you solve this particular problem. I will stop it right here.